So welcome to the lab portion of today's Tech Talk. And in the lab portion, we're gonna create this guitar note recognition software using artificial intelligence, machine learning methodologies. And to do that, we're gonna make use of this XG24 DK2601 eval board. So that eval board features our EFR32 MG24, and which has the matrix vector processor on it, which accelerates AI ML type of calculations. So to do this lab, we're going to program the board with some software that'll enable us to capture audio. So we're going to capture that audio inside a piece of software from SensiML, and we're going to label it. And then we're going to upload all of that data to the cloud and use it to build a model with. So we'll open the project in the cloud, we'll use it to create a query, create a pipeline, we'll run the feature generator, and then we'll run the pipeline. We'll be able to dive in and explore the model at that point, look at and test the model, and then finally we'll download a knowledge pack and put that into a piece of software that SensiML has provided and compile it inside Simplicity Studio, reprogram the board, and at that point it should be recognizing guitar notes. So real quick, we'll take a little deeper dive, just what's on this board. You can see there's a bunch of sensors on this board. And I'll say this is an inexpensive board to get your hands on. It's less than $40. But today we'll be making use of the microphones that are on there. There are two I2S microphones on there, and we'll be using those to capture audio with. There's also a built-in JTAG debugger. So we'll be using that port not only to program this board, but we'll use it for a virtual COM port to see data, to capture data with it, and then also to test it at the end after we've created our project. In the middle here, there's an LED. It flashes a certain cadence to let you know that you've programmed the board properly. I've opened up Simplicity Studio, and I'm on the Launcher tab, where it gives you a nice overview of the eval kit we're using and gives a description of the part that's on that eval board. Over here under the debug adapters, I've actually got my board selected, and I'm going to go over to the compatible tools and scroll down to Simplicity Commander. This is a interface that will allow us to do lots of things with the board. I'm going to select my board here. But one of the things it'll let us do is flash the device, and that's what I'm going to do. So I'm going to browse to this SensiML XG24 microphone capture. This is a pre-compiled bit of software that I'm just going to download to the board in order to get some software on there so that we can actually start capturing guitar notes. So there it is. I've got it all loaded up. I'm going to hit the flash button. So once I hit flash, you can see the steps taking place down here, and the flash completed successfully. I can hold up my board and show it to you, and hopefully you can see the LED cadence going back and forth between red and green, red, green. That's the indication that this board is up and running properly. When I originally ran this software the first time, this project the first time, I ran into an issue and I got stuck for a little bit. And what I didn't realize is I needed to set up the COM port at a certain speed for this eval board. So that's what I'm going to do here real quick so you can see it done. I'm going to go to the Simplicity IDE tab, and you can see the debug adapters are now down here in the left-hand corner. I'm going to right-click on my dev kit, and then I'm going to launch the console. And in the console, there's 01, 00, admin, debug. We're going to want to go to the admin tab, and we're going to want to give it an instruction to set the COM port to 921.600 baud. So here's the command: serial vcom config speed 921,600. And there you can see that it set the new baud rate and then gave us the actual baud rate that's calculated. We've reached the fun part of the project. We're going to capture some data, use a guitar to do it. I'm going to use a tool. It's this data capture lab tool. I downloaded this from SensiML. So this is one of the tools they provide. And it logs me in. I'm signed in. I am going to import a project, and this guitar tuning classification project they provide comes with a bunch of audio already. So if you don't have a guitar to do this with, it already has WAV files and stuff that you can use and do the project with. So I'm going to open this up. I'm going to click Next. And I'm going to change the name. I'll call that TT for Tech Talk and my initials. So this takes a second. It's uploading a bunch of WAV file information, which can be large. So it takes a second to get all that stuff imported into the project. So the project is all loaded up. The next thing we'll want to do is go to this live capture button over here on the left. I click the live capture button, and it does not have my eval board in there yet, so I'm going to add that. Change sensor configuration. And I'm going to add a new configuration. So I'll scroll down to the Scilabs XG24 Dev Kit and select that. Once I do, it gives me some information about it. I'll just click Next. And I need to make sure that my capture source is audio. So it's using the microphones to get that done. I'm going to click Next. And I'll give it a name. I'll call it Scilabs XG24 eval board. Save that. And I'm going to use the serial port as my connection method. So I need to scan, and it discovers COM8. So there it is. I'll say done. You can see down here it's connecting up to my kit, and I should get some audio. There it is. So we'll give it a little test here. So you can see that audio is coming across pretty nicely. One of the things I found out that's nice is if you take the eval board, and if you're using an acoustic guitar, you can drop it right into the sound hole and start to capture data with that. So that's what I'm going to do. I'm going to come over here to the Start Recording button and hit that. And I'm just going to save the data. And that's basically how you capture data. Now that we've got some data recorded, we need to label it so that the software can make sense of each individual sample and put it into the right bucket. So to do that, I'm going to go into the Project Explorer. And here's all the different WAV files. These first 4 WAV files are what loaded up when I loaded up the software initially. This one down here is one I renamed the untitled notes, and I renamed it Guitar Notes RGL1. So I'm going to double click on that and open it up. And it's moved down to this Data Explorer tab. And you can see the guitar strings are named E, A, D, G, B, and E. So we have 2 E's, so one's going to be E, the other one's going to be E1. But what we're going to do is we're going to highlight a portion of these waves, and then we're going to label them. So we'll come down here, And we're going to label that first one the low E. Come over to the second one. I'm right-clicking to highlight these, by the way. So I want to label that. I'm going to make that A. Done. Highlight this one. This one should be D. Label it. Done. This one should be G. We'll label it G. Here's B. Label it. And then here's the high E. And so that one's going to be E1. All right, so we're to the point now where we want to start building a model, and I've gone to the SensiML website, and all I've done is logged in. And once I logged in, it showed me all my projects. And the one that we've been working on today is this guitar tuning classification Tech Talk RGL. So next thing we really want to do is we want to create a query. So we're going to select our project. And we see a nice overview for our project. There's all the labels we used. I can see I did do 8 captures, so all of this looks like it's my project, the one that I want to be working with. I can go look at the data manager, and it'll show me all the different waveforms that I'm working with. The RGL ones are the ones that I added. These other ones are the ones that came with the initial project. So I'm going to prepare data, and in preparing data, I'm able to come over and create a query. So I'm going to create a query. I'm going to give it a name. Call it guitar notes. Session will be session 1. Label just remain label. We need to make this segment UUID be set. Yep, just like that. The source will be channel 0. And then our query filter will be set. And our source will be train. Say done to that. I'm going to save that. And that creates our query. Well, our data is prepared. We've created a query, and here it is, guitar notes. We can look at that, and it shows us some different things about our query, like the distributions of the different labels we put on it, and the distribution of labels by number of samples and that kind of thing. Everything looks pretty good, pretty even. The next step is really to build a model, which we're going to create a pipeline in order to build our model. And you can do this from scratch. You can build the pipeline from scratch. But we're dealing with an audio classification, so I'm gonna give this template a try. And I'll just say next. Next. So we're going to give this template a name, call it note classification, TensorFlow, because I know it's using TensorFlow. We're going to use the guitar notes query in order to create this pipeline. So I'll create the pipeline. I've already used that name, so I need to use another one. So my pipeline's been created, and I can go down and look at the pipeline and everything that's included in it. So I have saved it, and at this point I am going to run the pipeline and see how we do. And this running of the pipeline takes a little while, several minutes. So I'm going to stop recording and I'll pick back up when this is done. Well, I ran my pipeline several times and I wasn't getting great results. I actually reached out for a lifeline and contacted SensiML. Talked to a great FAE by the name of Chris, and he looked at my project. He's like, you don't have enough data. So I recorded 100 samples of every guitar note, uploaded those into my project, and ran the pipeline again and got really good results. So my accuracy is at 98%. So we can come over and explore the model and look at the training and also the validation. So the data got split, looked like about 80-20 between training and validation. And it looks like it's going to work pretty well. On the A string, it looks got like 1 out of 22 times it got confused during validation and called it a G. But the rest of the time, it was pretty much spot on. So this is looking pretty good. I'm to the point now where I can test my pipeline, test my model that I've created. And I'm going to do that. I came over and I selected test model. And I'm going to select all of the data that is 100 samples. I'm not going to choose the ones that are super small. And then I'm going to recognize and test the data. And this takes a minute, so I'll stop here and I'll show you the results as soon as it's done. The model test appears to be complete, and it looks like we did pretty good. Everything's pretty much in the 90s, some high 90s. So the B string's at 99.7. Looks like the A string's a little low, 78%. Everything's, everything other than that's 90% and above. So I am going to use that model and do the next step where I download and the knowledge pack and program my device. I've moved down to the download model tab over here on the side. And as you can see, there are lots of different platforms you can do this for. I want to make sure we're downloading it for our kit, the XG24 dev kit. So I'll select that. And here you can see there's options for this compilation that's going to take place in the background. So I want to make sure that I go down here, and here's the hardware accelerator. So I can turn the matrix vector processor, which is the part in this part that speeds up AI ML type of calculations. So I want to leave that on because it speeds them up about 4x. Also, the data source, I'm going to change that to the XG24 board. And finally, I'm just going to click download and start generating those files. I'm going to extract it here. And you can see that I get this knowledge pack. Inside the knowledge pack, there are files that I'm going to need in order to replace files that are in the demo project that you get from SensiML's GitHub. And I'll do that in our next step. In order to make the final project for this note recognition, you'll want to download from SensiML's GitHub the SensiML XG24 microphone recognition. And it's right here. I've already done that. I've downloaded it, and I've imported it into Studio. The other thing I did was, in the last step, we downloaded the knowledge pack that we had. And what you need to do is you need to copy this knowledge pack and replace the folder titled knowledge pack in the project. So I've already done that, and I'll take a second here and just compile this project. And the project compiles cleanly. There's a few warnings, but they're nothing to be concerned about. So once the project is compiled, we can go find those binary files. I'll use the S37 version of it, and I will flash that to my device. And so here we're going to program it. And our device is programmed and ready for test. We've reached the last step of this note recognition project, and there's a couple different things we can do. I've got TerraTerm here, and I can open that up and see raw data. So it's picking up my voice right now, but if I hit a note, you can see that it's classifying that note, but you can't make a lot of sense out of it in TerraTerm. But SensiML provides a Python tool, which I set up, and it does the same thing, but it goes in and fills in the holes with the rest of the data. So I'll connect to my device here, go to the test mode, and see how it does. That should have been a low E. That's an A. It was kind of flipping back and forth. D. The next one should be G. B. And then E1. So the note classification, the machine learning seem to do a pretty good job with recognizing those notes. I'm pretty impressed.